Okay, section 9.3, example 10, is the express lane faster? For their second semester project in AP Stats, Ori and John decided to investigate which line was faster in the supermarket, the express lane or the regular lane. To collect their data, they randomly selected 15 times during a week, went to the same store, and bought the same item. However, one of them used the express lane and the other used the regular lane. To decide which lane each of them would use, they flipped a coin. If it was heads, Ori used the express lane and John used the regular lane. If it was tails, Ori used the regular lane and John used the express lane. They entered their randomly assigned lanes at the same time and each recorded the time in seconds it took them to complete the transaction. So here's the data of the times. And what we really need to do, since it's paired data, is to take the difference. So is there convincing evidence? This is what we're trying to answer. Is there convincing evidence that the express lane is faster? Since the data are paired, we'll consider the differences. Regular, and you have to define that. Regular minus express. Here's the 15 differences. A positive difference means the express lane was faster. So here's our data. Okay, so we are going to state so we need to define this. So mu sub, so let mu sub d, the difference in the means, mu sub d equal the true mean difference in time. True mean difference. And its difference is regular minus express. In time. True mean difference in time. So h sub naught is going to be that there's no difference, right? Statement of equality. So mu sub d equals 0. Same amount of time. And then our alternative hypothesis is going to be that mu sub a, mu sub d is greater than 0. And this is going to be at alpha equals 0.05. I'm just looking at this and questioning it a little bit here. Regular minus express is positive. That means the regular lane would be faster. Positive difference means the... So I'm thinking... Is this stated correctly? Okay, it's okay. Regular minus express. True mean difference. Okay. Okay, got it, right. Because these are times. Okay, right. Thank you, yes. Slower means takes longer, which means bigger. Yes, thank you. Okay. So, h sub 0, h sub a. Okay, so plan, we'll do, we're going to just shortcut a little bit. Random check. Normal. If you were to plot this, it would be slightly skewed right. If you slightly skewed right. No outliers. And independent, I'll write it because it's a little bit different, because we're not removing, we're not like sampling things, but it's like flipping a coin. There's an infinite number of possibilities, so each trial is independent. So since it's like kind of different here, I'll write it. So there is, so you don't like show it's the samples, you know, less than 10% of the population size. It doesn't make sense. So there is an infinite number of possible times. So differences are independent. Differences are independent. Okay, so if you crunch the numbers on your data, you would get, we're going to do now, you would get x bar equals 42.7 seconds, and standard deviation, S sub x equals 84 seconds. So t equals 42.7 minus 0 over 84 over the square root of 15, which is 1.97. So on your calculator, the p-value is TCDF. I'll show you how to use the table in the next examples. So you would go from 1.97 to infinity. Remember for the t values, it's always the area to the right, whereas z, it was to the left. So be careful. 1.97 to infinity, and the degrees of freedom are 14. So you will get 0.034. So there's a 3.4% chance of that happening if what we state in H naught is true. And that's good. The p-value is less than alpha. So since p-value less than alpha, reject H naught. And there is convincing evidence the express lane is faster. I'm going to just write the express lane is faster. Okay.